So in this lesson, we're going to spend probably the first 20 minutes or so just going over the quick assessment that I got you to do last week on conduction, convection and radiation. It was just it's a useful sort of precursor to the energy resources topic that we've just started shortly after doing this test. And also, I was glad to see that quite a few of you have completed the Seneca task on energy types, which is again useful sort of pre-reading before we really start doing the energy resources test. So, excuse me. So what I'm going to do, I'm going to go through the paper. You've obviously all had your feedback. I've sent you back your marked paper so you can see how well you did, what you did well on, what you didn't do quite so well on. What I think I need to do really is go over this with you and talk you through what the answers should have been and what you should have actually done as part of that test. By and large, I was quite happy with probably about half of the class that you made a decent attempt. One or two of you, well, I'm going to be very, very frank. You know who you are. Being as this was an open book task and you should be looking up anything you're not sure about, so you can always look it up on the internet. You can always you can always look in your revision guide and your textbook. Really, you should have been able to do score at least half the marks in this. One or two people, I think, didn't give it their best shot, and that's a bit of a shame. But well done to those of you who did. There's some really good work. As I said, it was a 30-minute task, but I allowed you a bit of extra time to go on Seneca, and also wanted to see what you knew and what you understood, not just how quickly you could write. If we look at what the questions were about, I mean, question 1 to 7 was basic recall of conduction, convection, and radiation. So that was it. So most of you were able to do that pretty well. Recall of applications. The application I gave you was a thermos flask, or the dewar, as it's sometimes called. Some of you did very well with that, but there are a few misconceptions that I want to go over. And then we had a couple of How Science Works questions about insulation and thermal radiation, which is all about being able to look at an experiment and evaluate its effectiveness. Just going to make a note. Jethro's just coming in. Okay, I'm just making notes as people are coming in so that I know who's come to this lesson. Right, so as I was saying, this was the bit that I think also want to dwell on a little bit, because really this isn't just about science isn't just about learning facts, it's about understanding them. And when you understand the ideas around science, you start to be able to look more critically at things like experiments and your practical skills with it. So without any further ado, let's just go over the questions that were answered quite well. So which one is the worst conductor of heat? Well, the one that's actually the worst conductor of heat is actually a vacuum. Okay, if you think about it, if you have conduction, that's passing energy from one particle to another in a substance. If you've got a vacuum, there are no particles, there's nothing there. So you can't conduct through a vacuum. Why do people wear protective layers of clothing in the winter, and birds fluff up their feathers to keep themselves warm? So why is that? Well, it's the same reason, but it's a 2-mark question. So there are two things you needed to state there. And basically what you needed was the idea that they trap air, okay? So both methods trap air. And air, although it's not as good an insulator as a vacuum, it's still a very good insulator because all the particles are further apart. So in that case, we know that air is a good insulator. Okay, and that was all you needed. Sorry? No, okay. I thought someone had a question there. So those were what the 2 marks were for. So one saying that they trap air, one for then qualifying that. Why do they trap air? Because air is a good insulator. Why are metals better conductors than other solids? Most of you got the idea that metals, now you can't say they have electrons, you should say that metals have free electrons, because free electrons can transfer the energy from one atom to another much more efficiently, okay? So, but it's a 1 mark question, so you don't have to sort of develop it or anything. It's a 1 mark question, so it would be fine to say that metals have free electrons. Right, this one was not very well understood. Why is the freezing compartment of a fridge freezer often at the top of the fridge? Well, we sort of did a bit of revision on this. The freezing compartment's at the top so that the cold air sinks, and when it sinks, you then get set up that convection current that circulates air around the fridge, and so it keeps the whole fridge cold. That's the idea. Okay, so it's all about convection. It's the idea that if you've got a refrigerator, you've got your cold bit in there, you've got your sort of your freezer box, your freezing compartment in there. What happens is the cold air from it sort of sinks down, because this is warmer air. It then circulates and goes back up. So you end up with this circulating cold air, which keeps your whole fridge cold. Right, the main way in which heat can be spread around the room using a central heating radiator. Now, careful, because loads of people often say radiation. That's not true. If we think about it, the central heating radiator warms up the air around it, and that air then moves around the room, because it says in the way it can be spread around the room, okay, not transferred to the air. So it is that convection, and it's the opposite to the freezer, if we think about it. If you've got a room, there's your radiator. This is hot. As it's hot, it makes the air around it hot, which makes it expand, and therefore it rises up. It pushes air around the room. And as it pushes air around the room, you end up with a circulating air. So it's constantly heating up the whole room. So that's how it works. It's convection. Most people got this one right. So a hot cup of tea is poured into a bowl made from the same material as the cup. Explain how the rate of cooling is affected. Well, if it's poured into a bowl, then the surface area is going to increase. If you have an increased surface area, you will you'll lose heat more heat energy more rapidly. So the rate of cooling will be increased because the surface area of the tea has increased. Okay. That's the idea. It's very simple. Now, the next sort of the last factual question is, what color clothes would you advise for someone who lives in a hot, sunny country, doesn't have much shade, so in a hot, sunny country, they need to try and stay cool, so they would wear white. Remember, that's why traditionally sailors wear white, because they often sail to places which are hot, and as they sail to places which are hot, they need to try and keep cool, because it's not nice to sweat. Someone who lives in a cold country that has a lot of sunshine, well, if it's cold, they want to get warm, so they probably wear black to absorb the thermal radiation from the sun. Okay, so white reflects thermal radiation keeps somebody cool in the hot sun. Black absorbs radiation and therefore absorbs energy. And as it absorbs energy, it helps the person to stay warm by absorbing the sun's thermal radiation, that infrared radiation. So moving on, this was an application question. I want to spend a bit of time on this. This is a thermos flask, or a dewar. It's designed to keep drinks hot. It also keeps cold drinks cold as well. It just basically stops thermal energy from transferring from the outside to the inside, or inside to the outside. So which feature prevents the heat energy from escaping through the sides by conduction? Well, what you've got here is you've got a glass wall, and you've got another glass wall, and in between there's a vacuum. So your task really with this was really to look at the diagram and work out how it works. So you've got a vacuum in here. So this vacuum, we said before, was a really good thermal insulator. So what happens is if you've got a hot drink in here, then what happens is the thermal energy can't conduct from here to here. So it keeps the thermal energy in the drink. So it is actually the feature that prevents heat energy escaping through the sides by conduction is a vacuum. Okay, remember vacuum is spelt with 2 U's. Then says which feature, the next question says which feature prevents heat energy from escaping out of the top of the flask. Well, here we go, out of the top. So we look at the top of the flask. Well, if we think about it, if you've got hot liquid, it's going to be warming up the air above it, taking some of that thermal energy away. And as that air is warm, it'll try to rise up out of the flask, but there is a plastic cork in the way. So it's the plastic cork which prevents that, that convection out of the top of the flask. Okay. And last but not least, which feature prevents heat energy from escaping by radiation? Well, remember, it's white and shiny surfaces which prevent radiation because they reflect it back in. So this hot liquid's trying to conduct out, but it can't. It's trying to convect out the top, but it can't. So the only way it could still lose thermal energy is by radiation. But we have shiny surfaces. So here it's almost like a mirror. If you actually buy a thermos flask and look into it, you'll see it's shiny on the inside. And the reason why it's shiny is it's trying to emit infrared radiation, that thermal radiation, out. But what's happening, the shiny surface is reflecting it all back in again. Okay, so it is the shiny surface. Okay, that's the answer to that one. So that's the idea. So here we're not just memorizing about conduction, convection, and radiation. We're looking at a particular application and working out how it works within that context of conduction, convection, and radiation. So number 9. Here we're going on to experimental skills. So we're looking at an experiment. So a company's made a new material, it's called Wellwarm. They want to use Wellwarm to make coats. The scientists tested Wellwarm to see how well it insulated a beaker of hot water and used 3 other materials to compare it to. So she's wrapped each beaker in a different material. She recorded the temperature at the start and 20 minutes later. So what was the independent variable? Well, the independent variable, the thing she changed, because it's the independent variable, remember, is the thing that you're changing to see what effect it has. So what we're changing here is the material. And the dependent variable, the thing they're measuring, well, what are you actually measuring to measure how well it keeps the hot water hot? Well, you're measuring, the clue is on the picture here, it's the thermometer, so we're measuring temperature. Well, actually, we're measuring change in temperature, but it's absolutely fine to just say temperature. Okay, so here are the results of the investigation. You can see they all started at 60 degrees Celsius, but some cooled more than others. So we then have to ask the question, the scientists said that Wellwarm was the best insulator. They concluded that it was best insulator. So which one must have been Wellwarm? Well, we're looking for the one that has the smallest temperature drop. Well, this one dropped by 26 degrees. This one dropped by 22. This one dropped by 24. This one, however, only dropped by 20. So this is the one with the smallest change in temperature. So it's B. Okay, and so it then says use the evidence in the results table to explain your choice. So it's the idea that it had the smallest change in temperature. Okay, so that's the answer. It's had the smallest change in temperature. That's what I was looking for. Right, now this particular question, I think, gave a lot of people some headaches. It said the company made a coat from each of the 4 materials they tested, and a person tested the different coats by wearing each one in a cold room. He measured the temperature inside each coat for 30 minutes. So write down 2 other variables which should be controlled to make this a fair test. So the time spent in the cold room is already controlled. And it's a person, so they use the same person every time. So what we're looking for is are things that were controlled that it doesn't mention. So what else would you have to control? What else would you have to keep constant? Well, the first one is the temperature of the cold room. And you could then also make sure the person had the same body temperature every time. The person's body temperature. So those are 2 things that you would have to keep constant to make this a fair test. The other thing that's also pretty obvious, it could be any 2 will do, but also the third thing they didn't mention, but you'd have to keep it the same, is the thickness of the material. Okay, so because obviously if you make if you use a less efficient insulator, but it's really thick, then it will insulate better than a good insulator that's really thin. So they'd want to keep the thickness of the material the same. Next question is write down 1 thing the scientists should do to make sure the person testing the coats is safe. Well, what they're at risk of? They're at risk of getting too cold. So what you would do is you'd monitor the body temperature or their core temperature. The idea being that if that person starts to have hypothermia, then obviously their core temperature will start to drop. So you can get them out of the cold room early if you need to keep them safe. Having the person wearing insulation underneath the jacket, well, that's going to affect the results. So that's probably not the best idea because it will adversely affect the results of the experiment. Right, and then you've got a question here. Suggest 1 advantage of using a temperature sensor and data log instead of the thermometer as used in the experiment. Well, there are lots of advantages. Is the big advantage with using a data logger is you can monitor the change in temperature over time. But if you put in any decent advantage, you'd have got the mark. So another good advantage to using a data logger is you can monitor the temperature remotely, so you don't have to have somebody else with a thermometer in the room measuring the temperature. You put the temperature sensor on the volunteer, on the person, and you can be in another room, much warmer, monitoring that temperature over time. So that was that question. The last question, number 10, again, it's looking at an experiment, and this is how scientific discoveries are made. Is you look at something that you might already have seen, and you start to think about why it's like that. So, which elephant loses more heat from its ears? Well, it's actually the African elephant because it's got a larger area. So elephants actually cool down by having blood vessels in their ears. As the blood pumps through the blood vessels, it cools down. So the African elephant can lose more heat from its ears. Okay, the reason being is it has a larger surface area. Okay, so larger surface area means you can lose a bit more heat energy in a shorter time, whereas the Indian elephant is not in quite such a hot climate, so its ears are a bit smaller. So that's where we build a hypothesis. The hypothesis that the African elephant has the larger surface area. So your clue to that, to the answer to that question, is actually comes if you read the whole question before you start, because this is all about an experiment which simulates it. It's the idea the strip of metal is a bit like the elephant's ears. Okay, so you've got the strip of metal here, which is quite big. You've got very small sort of sticking out strips of metal on metal can be. And what they do is they record the temperature every 5 minutes for about 20 minutes. They're starting at the same temperature of 60 degrees Celsius. You can see that one cools down faster than the other. So we can use that data later on, but here it says Ben started with water at the same temperature in both cans. Give one other way he made his test fair. So one other way he made his test fair. Well, there are lots of things. If you look at what else you need to keep constant, that would otherwise affect the rate of cooling in this experiment. So you've got cans with hot water. Well, it's here, it tells you exactly how much you put in there. So one other way, other than having the same temperature in both cans, is having the same amount of water in each can. Okay, so that was your answer. You can say other things like using identical cans, using the same material for the strip of metal, but really this was the answer that we were driving at. So he then plotted the results on a graph and drew lines of best fit, a bit like you do with your experiments. Why is it more useful to present these results in a graph rather than a table? And the reason is, well, a graph is a way of showing a pattern. Okay, it's a bit like the government briefings we're having at the moment on coronavirus. They have graphs which show the pattern of change of number of infections, number of deaths, number of hospitalizations over time. So why is it more useful to present them in a graph rather than a table? It's the fact that you can see the patterns more easily. Okay, so you can see the pattern a bit more easily. So the water, we're coming to the end now. So the water in can A cools more quickly than the water in can B. Does this support your prediction in part A? Tick the correct box. So it says in part A, the prediction was actually right at the beginning where it says predict which elephant can lose more heat from its ears. And we said the African one because it's got a larger surface area. So here, the cans here has got a larger, this strip of metal's got a larger surface area, and if we look at the graph, we can see that can A cooled more than can B. Okay, so the water in can A, does it support your prediction? Yes, it does. And explain your answer. Well, it's the idea that the larger strip of metal had a larger surface area, and so cooled more quickly. Okay, that's it. So the last one then says, Ben repeated the investigation. Instead of using a thermometer, use the temperature sensor and a data logger. Give one advantage of doing this. Well, in the context of this question, it's the fact that you can automatically monitor the temperature, the change in temperature over time. So it removes any possibility of human error. Okay, and that's it. That was the that was the test. Now, as I said before, most of you about half of the class met or exceeded expectations, but some of you didn't do quite so well. So what did you do well as a class? Well, you did well on the first few questions, so you recalled facts, key facts well. But it's really, the thing you need to do is look at the applications. Look at how it's actually used and how it's and how experiments might be run. So how do you do that? Well, part of that is to focus on practical demonstrations. Okay, so in Seneca, for example, there were lots of sort of practical, there were lots of sort of practical sort of demonstrations, and also as part of the sort of showing you the pardon me, as part of my showing you as part of my showing you the sort of the PowerPoints, I showed you some films of some demonstrations as well. Okay, so that's sort of the main, that was how to do the test. Now what you need to do with that test, obviously I've given you your feedback, you know how well you did. Some of you are red, some of you are amber, some of you are green. Red means you're not meeting expectations, amber means you're kind of meeting it just about, green means you're meeting it or exceeding it. You do need, I think we do need, before our end of year test, which will come up in sort of June, I think that we need to spend some time sort of recapping this. Excuse me. But by and large, you showed me that you do have the essentials. Excuse me, I've got a bit of a frog in my throat there. So not bad. We've moved on now to energy resources, which we said last week was different to energy types. Energy types are things like light, heat, kinetic energy, gravitational potential energy, and so on. And we worked together to on your, well, you worked on the Seneca task to recap that. And this essential part of it was you saw that energy resources are where you get the energy from, where we physically actually get the stuff to make the energy. You can't make or destroy energy, you can only convert it from one form to another. It's an interesting question is how much energy is there in the universe compared to moments after the Big Bang? And of course, technically the answer is, as far as we know, exactly the same. It's just been changed into different forms of energy, because there are things like nuclear energy and matter energy and things like that. Yeah, that's going into sort of more advanced science, really. But what's important there is that you understand that we need to get energy from somewhere. Now, we looked before at the comparison between renewables and non-renewable energy resources. The idea that a renewable energy resource is one that shouldn't run out as long as we manage it. So this would be things like sun, biomass energy. Now, a lot of people get a bit confused by what biomass energy is. It's basically it's energy from biological matter. So it could be things like burning wood, for example. That's a biomass because you grow the wood, you burn it, but when you cut a tree down to get that wood and cut it up, you can then plant some more trees. So as long as it's managed, it's renewable. It doesn't run out. There'll always be trees as long as we remember to plant them. The sun is solar energy is renewable because the sun is probably going to be going for the next 6 billion years or so at the very least. So that's not going to run out anytime soon. Geothermal energy, well, yes, we're extracting thermal energy from the Earth's mantle, but there's a lot of it, and it shouldn't make very much difference over the next thousands of years. Whereas coal, oil and gas These are things that we extract from the ground. If we extract those from the ground, then what happens is they take millions of years to form. We're extracting them a lot more quickly than they're being formed. So basically we will run out, as I said last week. You're likely to run out of oil and gas probably within your lifetimes. That's the prediction. But then we're always finding new sort of sources of oil, coal, and gas. So maybe not, but eventually it is going to run out, and that's a stark reality. So it's important to understand about different energy resources. It's important to understand the pros and cons of different energy resources. I kind of spoon-fed you last week. I gave you a PowerPoint presentation. I gave you what I call my whistle-stop tour of energy resources, but now it's your turn. So for the next hour, I'm going to set you a task. And that task is going to be using the worksheet that you should have downloaded from Satchel 1 from Show My Homework. This gives you an opportunity to put your name in. It is in Word format, so you can type it if you wish. And what I'd like you to do is, for each sort of page, I'd like you to just pick out 2 key bits of information, particularly whether or not it's renewable or non-renewable, but also some key information like its key advantage and disadvantage. Now, you're not going to do this from memory. What you're going to do is you're going to use this website. It's darville.clara.net/alt-energ. Now, if you download it, this is a Word document. You can just click on it and it will eventually come up. So here's the Darville Energy Resources website. It tells you all about all the different energy resources, and it also tells you how much energy production, how much energy it's producing in real time. Ignore the year there. That's just because the title doesn't update. This tells you how much there's been produced so far this year. So we can look at the amount of energy. We can see, for example, that crude oil and coal and natural gas seem to be producing a lot more energy than anything else, and that's something that probably has to change soon. So what you need to do is you will need to know a little bit about the main page first of all. Well, the main page points out that actually most of our energy comes from the sun. The sun is the source of the light to make plants grow. Plants feed animals, including the little crustaceans, which died and sank to the seabed, which produce our oil and gas. They also feed the plants that make trees, which died millions of years ago and formed coal. Wind and wave energy is dependent on weather, and the weather is actually powered by the sun. The sun heating during the day, lack of sun cooling at night, and the seasons. That all comes from that all creates our weather systems, which basically the energy comes from the sun. The only exceptions are nuclear fuel, which is where we get uranium, because that's just part of what the Earth is made of, and also geothermal energy. Now, there's a lot of information, so all you really need to do is to pick 2 important bits of information out of the summary. So here are the 2 bits of information. Now, I want you to write in your own words. Please do not just copy and paste. Obviously, I'm going to see that. So please do not just copy and paste. Then what I'd like you to do is, for each page, have a go at the quiz. So there is a quiz. There it is. Click on quiz, and you can try and answer as many questions as you possibly can. And you can then put your quiz score into your worksheet. So I'd like you to make sure that you do that. So I'd like you to have a go at doing that, and you do that for each type of fuel. It looks like a lot of work, but actually it's not that long at all. What I'd like you to do is, no matter where you're at with this task, by the end of the lesson, I would like you to submit what you've done before tomorrow, please. So do that right at the end of the lesson. Just submit it. Just put it into Satchel and submit it. If you want to handwrite it because you can't print out the worksheet, that's fine. if you want to, but what you can do is you can actually download the worksheet. As you have access to school email, you also have access to Office 365. If you've got access to Office 365, that means that you can, that if you've got access to Office 365, that means that that you can actually sort of load it into Word, and you can edit it using keyboard, which is a little bit easier, I think, than trying to write it out. But the important bit is to go through as many of these energy resources as possible. Have a quick.
So basically, we have to.
So basically, you have to.
So we have to like press on the link and go to this website.
Yeah.
Then for each of the different types of stuff, we have to write two things, like 2 key points.
Yeah. So, for example, there's a lot of interesting stuff here. There's a lot you can read. You could spend hours and hours and hours on this, but I don't think I want to make you spend hours and hours on it. So it's sort of pick out the main points, but if nothing else, it's the summary, the key ideas. Pick out 2 things that you think.
We can just use the summary and then write 2 points in our own words from the summary.
Yeah, that's it. And then have a go at the quiz. Okay, and the quiz again, it's filling the blanks. It's quite easy to do. Okay, are you all okay to do that?
Yeah.
Yep.
Yep. Okay.
Yes, sir.
Yep. Okay. So what I'll do now is I will come out of Zoom for a few minutes so that I can then save the recording of this lesson, and then upload it, and then I'll come back into Zoom as soon as I can. The same link. So if you need to stop and ask me questions, please feel free. I'll stay online and stay in Zoom for the rest of the lesson. Okay, right. So you've got your task to do. Do your best with it. If you don't quite finish it, don't worry. If it looks like very few people have finished it, what I can do is just go over the give you a bit more time, maybe next week, to finish it off. That's absolutely fine. If you need a bit more time, not a problem. Okay, so I'll leave you to it, and remember, you can log into Zoom if you want to ask me questions for the rest of the lesson. That's till 11 o'clock. And however, if you don't, not a problem. If you just want to crack on, please make sure that whatever you've done, you submit by the end of the day today, please, even if it's not quite finished.